I'm Bill Young from Flatirons Solutions. We're based out of Boulder, Colorado. We're a gold partner with Alfresco. I gave this talk in Barcelona as well, so you have either the experience or the curse of hearing any changes that I've come up with since then. So what I want to talk about today is some experience that we had with a customer who had some very long-running batch-oriented processes that they wanted managed in workflow, and how we dealt with that using a scheduler to manage the resources and to allow queuing of those batch processes. Just a quick outline of what I intend to present. I want to give you the justification for what we were doing, what the customer was requesting, their requirements, and then how we went about looking at the problem and our analysis and our decision points that we had. And then finally, I'll talk through the solution. So, I already mentioned that they had some very long-running processes, 2 to 6 hours, that they wanted managed within workflow, processing large volumes of content, 50,000 documents or so. They were replacing an existing system which allowed queuing, allowed them to have users queue up the processes before they'd leave at the end of the day and let them run overnight and pick up the next tasks the following day. So we wanted to be able to queue the processes and not overload the system, but have them sitting waiting to be picked up when the resources became available. The system has limited resources. They don't want to horizontally scale forever, but they do want to try to use the system round the clock as much as possible. And we want the ability to be able to tune the system to change the number of active processes running at any given time based on how the resource consumption is looking. And we want to be able to do that through configuration. So make that as simple as possible for the administrators of the system. So this is, for the purposes of this presentation, a very, very simple idea of the workflow and the types of processes that they have. They want to pull these large volumes of content into the CMS, and sometimes the content's being versioned, so we need to identify already existing content. So there's a lot of database activity going on in that step. Then they have some conversion tasks that they perform on the content, so stripping out HTML tags maybe, or dumbing down some JavaScript, or changing some links or colors in PDFs. So some CPU-intensive tasks there, more so than repository and database tasks. And then finally, publishing step, which is basically just network traffic. They're publishing to an external system. So they just want to be able to pull the content out of the repository, copy a little bit of metadata, and toss it out somewhere. And in between all of these steps, there are some manual processes, which I've left out just for the purposes of this discussion, just to keep it a little bit more condensed on the slide. But at the end, I can show you, the full complexity of the workflow. Not that that's terribly important to what we're doing here. So we looked at what the customer wanted, looked at what we were able to do with Activiti and with Alfresco out of the box. And we noticed that just to handle the scheduling, Quartz Scheduler is already bundled with Alfresco. So it's a possibility. That was something that we could possibly use. And we actually considered trying to set up jobs within Alfresco to do a certain amount of polling, but trying to link that together with Activiti didn't seem really straightforward to us. Outside of timed events or timer-based events, Activiti doesn't directly support the kind of scheduling and queuing that this customer was looking for. And I'm seeing nodding. Thank you. I have an Activiti expert sitting right here in front of me, so if I say anything wrong, jump up and correct me so everybody doesn't get any bad impressions. But that was what we observed. But what we do have is the ability to have the process engine think something's going on and wait for the completion of a task. So we have the receive task. How many in here have done activity workflow within Alfresco at all? Okay, just a couple. All right. So some of these terms may not be familiar to you. If at any point in time I say something that you flat don't understand, go ahead and stick a hand up and I'll try to address it right away. Okay. So the receive tasks give us the ability to signal the workflow that something has completed and we're ready to move on. So just real brief notes about the technologies. Quartz, it's an open source scheduling library, fairly widely known as a Java API. So it made it very nice for us to integrate with the Java delegates that we were using for the workflows. And Activiti, of course, is the business process engine at the heart of Alfresco since 4.0. So go through a little bit on our solution. I want to talk a bit about the Java organization and the configuration that we did. And one thing that you're going to notice is that this really was fairly straightforward. We were able to do this in a really relatively simplistic way. Now, building out the additional capabilities such as dequeuing and changing priorities and things like that, the interfaces for those, that's where the real complexity came about. But to actually wire this into Activiti was not as difficult as we thought it might be when we initially got the requirements. So the first thing we had to do was look at those tasks, and we effectively split them. So we no longer have just a single state in the workflow for each of those long-running tasks, but we have two. We have the one that does the setup and kickoff, and then we have that receive task that's waiting for the completion of the scheduled job. We needed to customize the scheduler. Quartz doesn't know anything about workflow instances, and yet we still have to be able to communicate back to the process engine at the end of the job, and we have to be able to contain the information that's necessary for the job and hand it to the job when the time comes. Customizing jobs is a typical thing. You have to define what the job is that you want to run within the scheduler. So this was going to happen anyway. Of course, we're using Java delegates to represent that kickoff state for our service tasks. So we have a custom delegate that retrieves the necessary information that we need out of the workflow variables and our other data that we have. And we're going to do almost all of this. Almost all, not quite, but a very, very large part of it was Spring configuration. And we needed to define a job store because we wanted the system to be resilient enough that in the event of a failure, we would be able to pick up jobs that had been queued and get them going again, as well as work in a clustered environment. The customer has a 2-node cluster right now and looking at possibly more at some point in time in the future, and we want to be able to have multiple nodes in the cluster pulling the jobs off of the queue. So here's our revised workflow diagram, and what you see here is each one of these tasks has been split. So our delegate is tied to the first piece, and then we have the receive task, which is waiting for the completion of the job itself. And that's the case for every one of these. So it expands the workflow diagram, but there's really not any additional complexity in terms of what we really have to implement. So I want to talk about the delegates first, and I'll go through the delegates by I'll go through all of the code that we did by looking at the UML diagrams and then by looking at the code itself. But I want to do the UML diagrams to give you an idea of what the APIs are that we're using and how we extended them and implemented them. So if, I don't know if anybody in here, I think at least one person was in Gary Cox's presentation a couple of hours ago. He talked about using Java delegates. And we have the base Java delegate that's provided by Alfresco that gives us the core information that we need to interact with the repository. It gives us access to the service registry. So we have access to all of the runtime services within the Alfresco environment. We created our own abstract, very much the same reasons that Gary did, plus we had some additional information that we wanted to always make available to our workflow service tasks. And then we have another abstract, which is for those service tasks which would be scheduled. We have some service tasks within our workflow that are scheduled and some that are not. So there are some peculiar items that we need for the scheduled tasks. And then, of course, we're going to have concrete classes for each particular scheduled task instance or task job type. And the key components that we use out of Quartz are shown there on the right. We have the scheduler interface, which we are going to implement our own custom scheduler. Job detail, job data map, those collect the information that the job needs when it gets picked up out of the queue so that it can proceed on its way. There's no tie back to, there's no real synchronized behavior here, so you've got to store that information away and have it available. And then the trigger is the way that we queue up the information, that we queue up those jobs into the database or into whatever job store we are going to use. So our abstract Java delegate just extends the base Java delegate, and we provide one piece of information, and that's our custom workflow settings. So pretty typical, we have setter and getter, and those values are being injected. Then for our scheduled job delegate, we're going to have to know which scheduler. And part of what we did in this implementation was we allow a scheduler per job type that we had. So we had listed ingestion, conversion, publishing. We allow the schedulers to manage multiple jobs for each of those types, but one scheduler per job type. So we could have 10 ingestions running simultaneously with 4 publishes, but independently scheduled. And we have a way to modify priority. We have a way to set what the default priority is for jobs that are entered into that scheduler. As it turns out, there are a couple of supporting pieces that we need here. One of these is to be able to get all of the variable information that we have within the workflow that the job is then going to be able to need to connect back and be able to talk to the process engine. So we retrieve all the variables, all the workflow variables, and store them away into the job details. So what you'll see here is we're picking up the information about the workflow that's available in that delegate execution object. Again, Gary talked about that and talked about a lot of the information that's in there. So if you're not familiar with this, his talk is a good one to get some basics about working with the workflow and the Java delegates. The work package ID, that effectively is a node ref to our folder where we're storing the content. We have a folder within the workflow package. And then some various other pieces of information, due date, who the owner of the task was, who it was that initiated the action, the name that's going to be used to identify that work package, and then the priority if the user has set a custom priority for that particular task. The Java delegate requires implementation of an execute method, we could have deferred that to each one of the scheduled tasks, but as it turns out, the execute is common to all of them. The differences are in the scheduler that's used and the naming that we use to put the scheduled job into the queue. So we actually just implemented this at the abstract class level. So we saw the get variables map, so that's the first thing we have to do, get those workflow instance variables and store them away, make them available. We get that package ID and we use that for a couple of different things here in a little bit. So we're going to go look up our workflow instance. We're actually going to get that from the workflow service, and we're going to extract some additional information from there later on. We build up the job detail object. So we're getting a job prefix from the job itself. So this is actually, at this level, this is an abstract method. And we use the package ID to create a unique identifier for the job within the queue. We also have the group, and which is a way of organizing jobs. And then finally, we have the actual class that is going to be executed. That's the actual runtime class for the job. And we build up our job data map by extracting the variables and storing them into that map. And that map then is a serializable object that can be stored to our job store, whether it be in memory or whether it be in a database, as is our situation. We set that information on the job detail and we create a new trigger. Quartz provides a number of different triggers. In our particular case, the simple trigger was sufficient. We really didn't need anything. We weren't going to try to schedule jobs to repeat over time. Each one of these is a one-time instance, so we could take the simplest of the triggers. Again, we create a unique identifier by grabbing a prefix value for the trigger and appending the package ID. And then the group, again, is used for organizing. We'll see those concepts a little bit later. I set the priority based on whatever came in from the system, and I get the scheduler that's associated with this job, with this particular job type. And that's a Quartz call that takes care of putting it into our job store. So our concrete scheduled jobs are fairly straightforward. In this particular case, what I'm showing is getting those prefix values and the group names. Now, you're familiar with spring beans. You could look at this and say, well, when you initialized your delegate, why don't you just inject these values? Yes, we could have, if it were this simple. And I've left out some specialized code that we use that's very customer specific. But in a general case, if you just need those string values, you could certainly inject those as beans and take out a layer here. Same thing with getting the job class. In this case, our job class is this content ingestion job, which is going to be that custom job that we developed, that implementation of the Quartz job interface. So when it comes to the bean initialization, pretty straightforward. We have our custom workflow settings, some of the information. We've got the activity bean registry there. Again, going back to Gary's talk, he mentioned that. We encapsulate the service registry there, even though it's already available. We just put it all together in this one object that can be passed around. We do some auditing for this customer, so we have the auditing enabled. And then we're going to be caching certain information about the jobs, so we want to use a cache. The delegates, of course, our abstract delegate extends from the base Java delegate, which already exists within Alfresco. And all we're doing is setting that one object on that. Pardon me. For our abstract scheduled job delegate, the only addition there now is the priority button. And then, again, looking at our ingestion delegate, the only thing that we're injecting there is the scheduler itself. So let's move on and look at the scheduler. That's everything that went into our delegates. That's that kickoff step, just queues up the task. And now we're going to talk about the scheduler itself, and then finally we'll talk about the jobs. So the scheduler, again, is an extension of a Quartz class. We needed to do some very specific things in order to be able to communicate to workflow, to be knowledgeable about the Alfresco environment. And the scheduler is going to depend on a job. We have our own custom job. Quartz provides the job interface. And then for each of our jobs, we have the concrete classes there. So here's our scheduler. We need the Alfresco service information and some of that other data, the cache manager and so forth that we provided in those workflow settings. And we have a constructor which really does nothing but call back to the standard scheduler. But here's where the real work happens, is in the factory. We create a new scheduler and we make sure we get a scheduler of the right type. And then in the context, we're going to set some information that we get out of Alfresco. And then if you're familiar with Spring, of course we have the factory. Now we're going to have a factory bean, which we'll see in the bean configuration actually does the creation of the individual schedulers for us. So this is where we actually create the scheduler and provide the workflow settings directly into the scheduler. So the Spring configuration for the scheduler, pretty straightforward. Again, I'm using the ingestion as an example. First of all, we're going to create a properties object using the bean, the Spring Properties Factory bean, creating properties that will give us some of the information that we need, such as the prefix for the table naming within that job store, and how many, and in this case, how many threads we want running this process. So how many simultaneous processes can we have of ingestion at this? And then having those properties, we can now create an ingestion scheduler instance. Again, these are all singletons, which is fine for what we're doing because all we're doing is taking the information and queuing it. We have a startup delay here, which we define per environment. This is because when Alfresco is spinning up, the Quartz schedulers get created, and they may try to go immediately pick off jobs from the queue. And if that happens before Alfresco is fully up and running, we have some significant problems. And you can see the other pieces of information, the workflow settings. We provide a name for the scheduler that we can use to identify it. And then, of course, the properties. So, we've got the delegates. We've got the scheduler. We're able to communicate. When we get that call to the delegate, we're able to call out to the scheduler. We just need the job information in order to put that out there. So I mentioned the Quartz job interface. We have our own custom job, the job execution context, which carries some information that the jobs will need, and then our concrete implementations. So again, you're going to see this is some fairly straightforward code, except for all the details of what happens within the job. Of course, I've left that out because that's 99.5% of the code, actually. The rest of this, though, getting it wired up is really straightforward. So the job has an execute method as well. That's defined by us. We make an abstract method execute where we're going to expect certain information that comes out of, that we get from the scheduler when the job's actually started. The job interface from Quartz defines execute, and all it provides is that job execution context. So from that context, we have to extract the information and follow through, and really all we're doing is calling that execute method, our execute method that we've abstracted here. And then the last line that I'm going to expose here is the real magic. We have to signal the activity engine that we're done when we finish. So we use a completion, we signal completion on the task. All right, so our concrete custom jobs are going to be fairly straightforward. We're just implementing that execute method, and just for the purposes of the abstraction, I've abstracted that out into a completely separate class, but that's where all the real work is being done. But we get the information that we need passed in from the execute that we get elsewhere. So the real tough part when we were designing this was figuring out just exactly what we needed to be able to wire back to the workflow engine and get everything that we needed to be able to move things along and not be missing any information that the jobs were going to need. And that's why we have that custom job details construction that we had to do. But once we tackled that, everything we needed could be abstracted out to just a couple of additional variables here that had to be passed in, a couple of additional parameters that had to be passed into the execute here. Quartz is very configuration driven. So we have a Quartz Properties, and I did skip over that when we looked at the bean, unfortunately, yeah. We actually pick up a default set of properties that I'm now going to look at. And those properties are just sitting out on the class path. So that's the default set, and then we customize any additional properties that we need specific to the job type. Okay. So 3 key pieces, or actually just a couple of key pieces, but I've grouped it into 3s. The last 2 are very closely related. But one is, what's our pooling that we're going to do? Quartz provides a couple of different pooling implementations. We just needed something very straightforward. We just need to, have a pool, a fixed size pool that we could just pull threads off of as we had jobs come in ready to be executed. We specify here that we want to use a transactional job store, a JDBC-based transactional job store, and then specify the drivers that's appropriate for our database engine. And then there are some additional properties in here, not particularly important to the discussion, but Quartz provides a JDBC connection. We can specify whether or not we're in a clustered environment, some amount of intervals for how often the queue gets processed, and then the connection details for the JDBC, for the database. The JDBC Job Store has to have tables which are structured in a specific way, and Quartz provides that for you. They have examples for MySQL, for H2, for Oracle, for a number of different databases. So we just had to create the tables that we need which matched the prefixing of the table names. And Quartz already has that set up as well. They use a prefixing so that you can have a database which can be tied to multiple different schedulers. You just tell Quartz what the prefix of the table names is, and then all the tables, you have a job details table, you have a triggers table, trigger listener table, and so forth. There are a number of tables which we'll see in just a moment. But they're all named just by prefixing this string. So this is my prefix for the ingestion tables. So we just modified the scripts that were provided for MySQL and for Oracle, the two databases that we targeted, and we just copy and paste and replace. So these are the tables that exist for any given job type. So starting here with the blob triggers and moving on down here to the trigger listeners. These are all the different types that exist, all the different tables. The two that are most important to us are the triggers and the job details. Triggers is where we put the item into the database and say, I've got something that I want queued, and the job details is where we actually store that serialized map of variables that we need. The triggers table shown here, you can see these names, the trigger name, that's what I've created by prepending the fixed string and then the job ID, the group, which allows us to organize the triggers here within the table, and then the job name and the job group provide the keys into the job tables. So there's an example. You can see I had ingestion trigger as that prefix name there, and then here's the actual name that was given to the work package that I had. In my case, I'm just using readable strings, although these could be generated IDs of whatever form. What you'll also see down here on the end is the state of the trigger. In this particular case, I have one that's been picked up and is executing, and another one that's queued that hasn't started yet. Then the job details, similar. We see the name and the group. We see the class name. That's another argument that we had to provide. What's the actual executable class to run the job? And then our job data is stored as a blob here. And that's what it might look like. My job name, again, just the simple concatenation of those values. And you see here the actual class name. That's it. That really is all we had to do to get there. We had our service tasks already effectively written, working, and then the customer came along and said, but I want to run X number at a time, and I want to throttle it. So that's really all we had to do to take already existing service tasks that were very serialized and allow them to be scheduled and queued. Now, of course, there are some additional features, some additional things that we needed to be concerned with. The customer wanted to be able to look at a list of the queued jobs and change priorities. So we developed a share page which allowed them to, which basically had a web script that pulled the information out of that triggers table for all the jobs that were in the waiting state and gave the capability to go in and change the priorities and then write that back into the triggers table. So that's part of why we had to customize the scheduler, so that we could write back to the database that way and communicate. Clustering, we had to provide clustering support. So that, again, that's why we went with the JDBC Job Store, but we also have to provide some very specific information within the Quartz Properties to turn on clustering and to allow it to allow the system to know that it's in a clustered environment and therefore has to do some more transactional things that it wouldn't do otherwise for performance reasons. And the customer wanted to be able to remove jobs from the queue. And I don't know that any of you were in my earlier presentation on the workflow dashboard that we had, but one of the actions that we have on our workflow dashboard, if you look back at that presentation, is a removal of a job from the queue, a queued job. You'll be able to click on that action button and pull that job off of the queue. So that was important to this customer as well, and again, part of what we had to implement in that custom scheduler. Just give recognition to my colleagues. Sri Patil was the primary developer at Flatirons of this. I can't take credit for very much of the code, what, as little as there is that you saw. I mean, you saw almost all of it that wired this together. But he and I sat down and designed this and worked through the details and what the options were that we had. I did promise to show you what the workflow looks like, so let's see if I can bring that up. Yeah, so that's really the full workflow. And so, what you can see is, I keep forgetting I have this nice little laser pointer. We have a classification step. That's one that I didn't mention. So we see we have this is the kickoff of that, and the delegate that queues, and then we have the receive task here. And ingestion was one of the first steps in the workflow, so we have ingestion there and the receive task here. And we talked about conversion, we talked about publishing. So it's a little more complex than that simple, and you can see there are a number of user steps at various places in here. But for purposes of initial examination, the smaller workflow certainly works. Any questions or comments? Yeah. Here. Oh, yes, I'm sorry, Mike.
Yeah. So what happens if it goes wrong? So suppose that for some reason the invocation of the job fails. Is that something you take in account, or for this customer it wasn't important, or?
For this customer, it wasn't terribly important. We do fail the job. We do recognize it, and you notice that the signal was in the final.
Yeah, indeed, yeah.
So we'll catch the exception. We'll log it and report it back to the customer. But they were not concerned with restarting. Quartz does provide that.
Right. Now that's good, because we got a system in Activiti which does something similar, which we call the async continuations. But I think that Quartz is probably more mature than the stuff we have. So it's an interesting trigger for me to look at if we can use that. Actually, that was a very good thing. Now I got two remarks for you, how you can optimize your stuff even more. So now you split up between the invocation and the receive task, right? Mm-hmm. That's because you're using a Java delegate. Now you could use an activity behavior. That's an internal class. It's a little side note in our documentation for pro users only. But in that case, you could make it one service invocation, which does both the call and the waiting. So you wouldn't need to do the split up in the two. So that's one.
What version is that available in?
It's actually from version 5.0 already. It's one of the first things, but it's a very small side note, and none of many people know that it's possible.
Good to know.
Now, what this is, this is visible, but some people don't want it to be visible, and you could use, instead of a Java delegate, you implement another interface, and it exposes both the execution, as you did for the delegate, but also the signal, so you could do both. Anyway, just a side note.
That's great, because our customer looks at these workflows.
Yes, and you could simplify it a lot just by splitting it in half. Yeah, and second one is that we've got that's a new feature for Alfresco 4.2 is that I think Activiti 5.11 has a concept called parse handlers. So it allows you to hook in whenever the parsing happens of the process definition. It allows you to hook in custom stuff, and what you could do to implement this is basically take whatever logic you have in your Java delegate and wrap it, at parsing time in a custom job the way you do it now manually, right? Well, manually, programmatically. You would say, okay, if I've got a service task of this type, just wrap it in something that Quartz can understand, and you would, be able to simplify your code even more if you want to do that. But that's a new concept for Alfresco 4.2, which we didn't have before, but it's pretty powerful to add, basically wrap things in other things. So anyway, just remark.
That's great to know. I appreciate that. I'm going to have to go back and get the recording because I didn't get that all written down.
So thank you.
Terrific. Thank you. That's beautiful. Any other questions or comments? All right. I think there are some pubs waiting for us. Thank you all very much.